Okay, so I'm gonna explain this like as if I was talking to my boys when they were in 8th grade, because it really takes like a level of 8th grade science to understand it. But I also have a picture and some notes drawn, so let me show that to you. All right, I have never, ever, ever claimed to have good handwriting, but here we go. So this is the folate pathway, and here's what other people are also getting wrong about MTHFR. Folate is B9, folic acid, folinic acid, B9. These blue circles are the circles that have to do with the genetics, that have to do with methylation. So as you can see, even in this folate pathway, which is the methylation pathway, because this is the transsulfuration pathway, this is 1, 2, 3, 4, 5, 6, 7 different genetic factors that play a role in methylation. The notes are things that like I found important or interesting. The little green bubbles are like halfway points for different things that get popped out of the different cycles. So the main thing that you want to remember is that there are 7 genetics involved in the folate or methylation cycle, and then we go into the transsulfuration cycle. Now, here's why everyone's so focused on MTHFR. See how there's 2 genes down there that are dependent on, again, not B12, riboflavin or B2, and methylfolate, which methylfolate is B9. So you have 2 of those compared to these other 7. And some of these other 7 are important and you need to understand what they do. Like this DHFR uses NADPH, so NADP plus basically. The end result of this folate cycle is we're trying to kick out a glycine molecule. Now, MTRR and MTR are rate limited by your body's ability to absorb and utilize B12. But everything from this folate cycle, if you notice, does overlap with this transsulfuration cycle. So you need B6, B9, B2, and B12 to have a healthy pathway, and you need NAD. Now, in this pathway, we need B12 and choline. We also want dimethylglycine and methionine. We also need magnesium, SAMe, and we want to produce through this cycle as well, through some other genetics, acetylcholine, choline, and betaine. You'll notice in here as well that choline genetic is BHMT, gets dimethylglycine, or choline transfers into betaine. What's important about betaine? Betaine helps this cycle move a little bit more efficiently. It's also important for muscle building, cardiovascular health, and a healthy body composition, so it helps you lose body fat. Betaine is an amino acid. Amino acids are proteins. They can also be peptides if they're small enough groups. And here's what I want you to focus on too. B12, SAMe, magnesium, and the COMT gene, we get S-adenyl homocysteine. S-adenyl homocysteine. That then gets converted into homocysteine, and the homocysteine then follows a different path through different genetics, the CBS and CSE genetics, to basically kick out cysteine. Glycine from this pathway plus cysteine from this pathway give you glutathione. So I hope that that shows you that if our goal is glutathione, because otherwise we end up with too much sulfur, or you can see homocysteine going back into the pathway here. If our goal is glutathione, if this is what we want to get, but we are giving the body this and telling it, you don't need to produce this, I've got you covered, then this pathway dumps more homocysteine back in, as opposed to moving down this pathway to get glutathione. So the different things that you could check in the blood work to see if you're methylating would be, you could check for the level of B vitamins. You could check homocysteine. Homocysteine's like an $18 test deal. Like if you want to go in and pay cash for it, it's like $18. You could also check what is called the SAM-SAH index. Now, why could you check that? Because if you remember from the picture I showed you, you have SAM-E, COMT gene, SAH. So SAM and SAH need to be in a good ratio. The larger that ratio gets, the faster you're methylating. The smaller that ratio gets, the slower you are methylating. So if we have a homocysteine above 7, which normal labs will tell you can go all the way up to 19, but I'm going to tell you that that's getting like a C or a D on the exam, and you want to be getting an A. So if you get above a 7 on your homocysteine and you have a SAM SAH index that is above 5, then we know there's a lot of inflammation in the system and we are not getting enough glutathione output. We're stopping at homocysteine. Other things that you can do to then increase that transsulfuration pathway would be that you could cycle in 30-day cycles SAMe, because you cannot take SAMe constantly. You could add choline and betaine or trimethylglycine as supplements. You want to avoid any food that is fortified or enriched because it has traditional folic acid in it, and you may have difficulty converting that folic acid into methylfolate, which then gets converted into methionine, which then gets to be in that methylation cycle pretty easily. Now, one of the other steps that I didn't talk about through the PEMT gene with choline, because choline works in 2 different genetic pathways, is that through that you also get what's called phosphatidylcholine before you get acetylcholine, which then gets converted into betaine. Phosphatidylcholine supports the health of the cell membrane. So everyone's standing there talking about MTHFR, but they're ignoring, that's 2 genes, they're ignoring the other 10 genetics that have to do with that whole pathway that basically gets you to lower homocysteine and better glutathione, which is the anti-aging antioxidant in the body. And yeah, sure, urolithin A is great and you also need that, but glutathione is the #1 antioxidant used throughout the body. The #1. And your body would prefer to use it because that means that you'll have a lower homocysteine, which means you'll have lower inflammation. But again, if 40% of the world has a double mutation in that MTHFR and 60% has a single mutation in that MTHFR, and you're telling me that MTHFR is the cause of all of your illness and that that's the reason why Americans are so sick, I'm going to call your bluff. It is quite literally one of the most common epigenetic factors facing the world. And this fascination and phenomenon with MTHFR is a US only thing. Literally, it's an American only issue. All of that said, if you want to go back into like farming practices and what changed in the 1970s and look at how that like made this worse for us, go down that rabbit hole. I encourage you to understand how your food has changed and how its sourcing creates or helps with health issues. But the bottom line is don't over supplement and don't use things that have fortified or enriched flour.